Hello, welcome. I'm Bill Wake. We're here working on an old basic program, 1980s era, and we've done a lot of work to get it turned into Swift, and we're mostly using Swift constructs, but not completely. So my goal is that we finish restructuring it and get it turn it into a structured program, get it using modern constructs, and then we can start some more serious refactoring. We've done some along the way here. All right. This is an unusual time for me. I've got another job during the day this week, and going forward, so I've got to work out a new schedule for things. But we'll start here for now and see what happens. All right. Um, Let me kick off a build, and let's take a look at what we got. Okay, so we've got some things going on the to-do list. We've got a lot of GOTOs kicking around still. Not as many, but we still have some. We need to get basically to turn it into a structured program. We need to eliminate most of those or all of those. We've got a variable lost, and it looks like it's acting like a Boolean. It's a little weird, but we probably can turn it into Boolean. We think the name R really should be seed. X is being used in the keyboard subroutine. It's just kind of anonymous variable. We think LA is probably like level. All right. So what we've been doing, we have this notion of a come from analysis. So you have a bunch of GOTOs. Well, the blocks that are interesting are the ones that are targets of GOTOs or go subs, or for next kind of acts like that way too. But places you can end up when control transfers, and there's sort of a choice of where to end up, or just no choice at all, like a GOTO, but conditionals have a choice. And once you've identified those blocks that have an entry point, they can have multiple exits. But if you start a new block as soon as you get to the next entry point, then you can kind of simplify the code inside that block, and we can look for blocks of code that are only entered once, and we can also look for blocks of code that only have one thing targeting them. So if the only code, if you're line 70 and the only way you got to line 70 is because there's one place in the program that's GOTO 70, well, you can pull your code up to where the GOTO 70 was. All right. And also this analysis lets you do subroutine inlining if you realize it's only called once, or you can extract it. And in our case, we did an extract to make a helper subroutine. Let's see. Today's the 14th. Uh-oh. It's going to be slow on me. Okay, well, we'll get that set up. Can I? Well, oh, there we go. Okay. The network's looking a little odd too, so we'll see. I don't know. It's something about this combination. I think of trying to start the simulator and do the tests and run all the Twitch related stuff. I think it just gets to be too much for it some days. But all right, let's look at our basic. Now, I'm not sure what was changed here. We need to check that in before we go too far. All right. Well, while that's going, so what we still have left is we got a main for next, and then inside that there's another one, and in the middle somewhere there's a jump that jumps from the middle of the two for loops back to the start of the first for loop. And it's basically like, oh, you lost your life, this, you're, you get 3 tries, so you've burned 1 try, and it jumps back to the start of that. It's not the most unstructured thing ever, but it's a little weird, and we're gonna have to work around that one. I think where it gets really hard with the structured versus unstructured, it's like if you're jumping into the middle of loops and stuff like that, then it seems, it's very hard to know what to make of that. Jumping out early, it's not strictly structured programming, depending who you listen to, but it at least it's mostly compatible. Just like having a return statement in the, you might use at the top of your routine to find out, does this routine, do the arguments meet these criteria to return anything? If they don't, just return out early. Again, that's not the single entry, single exit that you get, but it's sort of close enough. The essence of it is the same, and same thing like the break statement in for loops. I don't know if I can. Let me see if I can search. No, we're really tied up. Okay. Well, I guess there's nothing to do but wait for this. Waiting for phone to start. Okay. That's apparently a tricky deal. But we ran it last time, so it should be okay. Well, I clearly have a couple minutes. I'm going to grab a drink. I'll be right back. Hopefully things will pick up by then. Oh, I see we've progressed to a spinny ball or bar. Let's see if the IDE has popped up our basic yet. No. It just seems like the slowest movement ever. Well, I don't know what else I can. All right, I did print a paper version. Let's see, anything else going on? Okay, so we did extract the subroutine that basically reads the keyboard and figures out, did you lose? And if you lost, it prints boom and prints your score. The rest, there's a little bit of trickiness around the bottom of our loop. I think we can make that okay. The other thing I think we'll notice, most variables we can just translate directly, and I've just assumed ints for now because it looked like everything starts as an int and ends up as an int. Mostly it's talking about addresses of the screen memory and stuff like that, maybe level numbers and so on. The only floating point I'm aware of is random number generation, and then we convert that to an int anyway. But the variables that we can't do that way are the ones that show up in the for next. We basically put those in a map, and then we have to maintain a stack. So whenever somebody starts a for loop, we push on the stack, and when they finish, if the for loop completes, then we pop that variable stuff off the stack, and that maintains the nesting of the stacks. Now, at least these old basics, it's not the language doesn't sort of enforce things at the text level like you think of braces in C or 8 million other languages. You have to balance your parentheses and stuff like that. Basic doesn't care. You can have 3 different loop endings that say next X, and depending which one you jump to, that's the one that actually does the work. That there's nothing like that in structure or structured languages. It's a very dynamic kind of view of things, and so because it's dynamic, we need to be able to update those variables and manage. In most languages I would take the address of them and all that, but Swift really tries hard to not let you do that. So instead I put them in a map, and you basically look them up, and to update the next loop, you look up the variable and then index it and so on. Index it into the map, find the value, set the value, and go on. We would like to get rid of that. We'd like to turn those into regular variables, and we can do that once we get things structured. But until then, it's going to be tricky. Okay, the build, I thought I said run tests. Goodness. All right, there's our basic. So let's see if I can show you where I'm talking about. Okay, so down here, this is all a subroutine, and we have it isolated. I don't think it's a great subroutine, but it's a subroutine. It's got side effects. Okay, but in here, it gets a little tricky. So you see, let's see, for NA equals 1 to 10, for LW equals 1 to 20 plus 5, whatever. Those 2 loops open here, and they close in 130. And we do go sub, but we also jump. If low, then jump to 200, reset low, clear the screen, go to 150, and then if you like what's there, then go back and start over at where's that target? 95. So start over on the 4 loops. So there's bouncing around here, and then some. If you don't do MM is like the number of turns you have left. If you don't have any turns left, then we end the program. Let's see where. Oh yeah, here we jump 200, and then go to 150. Okay, and I think we've folded some of this up. Let's see what we got here. And at this point, we've taken stuff out. Most of the comments are gone. Actually, I think that one's not adding anything at this point. Poke 530, but let's see what the diff is. I have a bad habit of forgetting to check in when things have changed. A blank line. Okay, I'm not too worried about that. That's me highlighting. Okay. All right, so we'll take a chance on this. All right, LA equals LA plus 1. We got rid of some, but not all. Go to 150. So I'll leave the 4 loops. Okay. Right. So, I mean, when we started, we had, 50 or 60 lines of labels. Now we're down to a few cases. We got 95, 96, 97, 100, 130, 131. It's kind of a helper line. And 141, 150. Okay. So we're down to half a dozen or so. Right. How's this coming? Slowly. All right. Okay. I'm going to take my chances that I've edited these lines correctly. Remove useless comments. Okay. So, in the name of getting things structured, we want to try and get rid of these line numbers. Now, some of them, let's see. This one is really only referenced, well, it's implicit. I have well, let's do it this way. The way it is now, we run around looking for the line number down here. And we just force ourselves to find one. Eventually you'll run into the start line. We're just going to hard code the start line because that's going to we'll get rid of that at some point. Now, I don't really have tests for this code that we're refactoring, so we're basically running it manually to do the testing of it. And I don't know, it would be hard to test. I'll say that. It's becoming easier, but I don't know. Maybe we could probably work something out, some sort of characterization test. If we hard coded the path, like how do we move the ship, and we've got a deterministic random number generator, so you get the same path every time. We could probably work out something. All right, but tests are okay. All right, so let's just set starting line number directly. Okay. And I'll kick off our run just so we can see that. Okay, now the trickiness that we have, these references, let's see, this one. So a for loop, we've got a method that says, tell me the line number of the loop body, and that's where I'll know to jump to. And so it basically does a go to 100 in the for loop, and then ends up here, the next statement. And these old basics, they always execute their for loop at least once. For whatever. Well, I think because you don't know where the next statement is. So, like, what are you going to do until you hit the next statement? Well, it could all be conditional logic to get you there. So you can't really know what to do unless you go do it. So they just do it once. Let's see. Can we get rid of something else? 150. Okay, maybe we can do something with this. We got this go to 150. Let's see. And I think that's the only target of 150. Let's make sure that's true. 150, 150. Yeah. So here's a case. The only target of this is 150. So it's a single target thing. So the body of this, I can pull up here and do instead of go to 150. Okay. Notice that each path in it ends with a go to 95 or 0, which is end. Okay. And nobody should be referencing this anymore. So I should be fine. We had an implicit one. I'm here. You'll see me break something. Okay, because we did do the fall through. So let's see. So I'm using my arrows to dodge these things, and I ran into it. Okay, so yeah, we can't see the problem here, I guess. But the deal was I copied that stuff up to the place it was used, but you can also get there through here. So we really need to put that code here too. And it may be a bad idea that we have these two places, but we are being consistent. So this becomes a break now. All right. I left out a brace. Okay. All right, so now we do the LA plus 1, then we go to 95. All right, so this is after the loop. We increment LA, which we think is level, and if we still have lives left, we go back to the very top. Otherwise, we're just done. Okay. Now this is almost this is kind of structured in a way. Like we got through the whole loop, and at the end, we're doing a decision based on lives remaining. So you could imagine this being a repeat until lives remaining, equals 0 or less than or equal to 0. Okay. Now this one here is funnier. This is, in effect, we're getting an early exit here. So if the lives remain, we're in the middle of the for loops. If we realize we hadn't yet lost, I don't know. If the lives remaining is greater than 0, we're in the middle of these for loops under some circumstances, and if we come back and it turns out that we lost, so we hit a boom, we want to go back to the very top again. And if we're just out of lives, then we want to exit right here. So this is almost like it is an early exit form. We got some duplication because that's the way this came out about. All right, now I think we're almost to the point. Let's see. So let's see if we can figure out the inner loop. Okay, so I think we can look at the body of this. So 97, 100, and 130, that's the inner loop. All right, if we exit, we go to minus 131. Okay. I believe we can transform this. So let's do that. So 1 ... and everything's 1 based in basic. So we will do, oof. Come on. Now, I don't know if we have LA anymore. I'm going to put this in a parentheses. Okay, we do have LA. All right, so all those for each. And then here we're going to say LW in. Okay. I don't know if we have LW still. We may have to go back on that. All right. Now, where does the loop end? It's the next LW here. Okay. All right. And now we got to adjust these breaks. Okay. So that's taken the place of this. There's no more break. Okay. So the body of the loop is all that. I think we're going to look what LW is. A wavelength. Wavelength. Okay, so let's call it wavelength. Wavelength. Okay, so for a wavelength in 1 through this stuff, do this part of the body. And then otherwise we're ending here. So I think these 3 lines go. And this is part of the old thing. Okay, so I'm not quite sure we're quite right. This is ending our loop, but how are we doing on the? We got to make sure each path goes through a GOTO. So go to 95, go to 0, else go to 130. 130 is this. And that means, so what he would do, the next would go to minus 131. So I think in this case, we're going to go to minus 131. And this has to be in the loop, in here. Let's see. We want to go to 130, so we want to do the loop thing, and then we want to do the GOTO. Shoot. This is tricky. All right, it's this lives remaining thing. So if we're doing this stuff to go backwards, we have to, or exit, we have to make sure that when we do this to go to the next LW, okay, speak up if you see what's going wrong here on me. I don't want to do this here because that's outside the loop. So whatever I said go to here is not going to be correct. So can I pull this? No, it's all in this lost case. Okay, so I'm gonna, oh boy, I hate to do this, but I think I'm gonna have to put some state in here to tell me that I did lose at least once. I mean, I got to know if I'm going to 95 or 0 or the follow-up. So I think I'm going to set a flag. It's going to get clear. Well, let's try it. var should, how about already exiting? We'll start it out false. Okay. The only way you set this flag is one of these two cases. Well, I guess both of these two cases. So let's set it here. Okay, so if it ever comes true, we get to the bottom of the loop, go to 130, should run the next loop. I don't think I need this case now. Okay, and I'm going to say if not already exiting, go to 130 minus 131. How's that going to work? Expected greater. Oh, yeah. No one-liners here. Okay, so I'm saying if you already set an exit point 95 or 0, then we want to honor that. Otherwise, we're going to go to 131. All right. I don't know. This is one of these big steps. No tests. Ugh. But a flag does get you out of some of these situations where you're kind of worrying about these multiple paths. It's kind of a not great solution, but okay. And notice these are the same. That's the same path. I see these two stars together that always show up. Okay. So I think I have successfully done it. All right, let's check it in and then we'll clean it up. Okay, so turn the innermost loop into a swift loop. Okay, so let's take out this stuff. Whoops. Well, I'll take it out and reformat in the end here. Okay. That. All right. Okay, so let's remove comments. Oh, did I not? And we'll just do a build. Okay. Okay, so now 97. I think this is the only 97s, the two. All right, so I'm going to 97. I break, and then I get to 97, so I don't need any more stuff in the middle. All right. We'll do our manual test. Yeah, I do think we can find a better way to exit out of that loop and all that stuff than the flag. I just think we got to get these loops native first. All right. And you can see that double line of stars there, and then we'll boom in a second. Okay. I'll stop. Okay, so eliminate go to 97. All right, we have another loop. 96, 131, and then goes to exits to 141. All right, let's try the same thing. Okay, so this is 95. We need a for loop. Well, this one's easier. Hey, to miss 12. For each, and I'll just put that here for a moment. What is it? Well, it's asteroids per line. In. We'll take this down here. We got to put this to the end of the loop. His next is here. Okay, so now we need to make sure we don't want to execute this. And again, I'm just going to comment as I go here. Okay, so I got to get I can have no case, no GOTOs, basically no case labels or statement labels. All right, same thing here. Okay, now this go to 131, that's going to the loop exit. Okay, so this should not matter at this point. We've gone to 131. Okay. But we still want to let's see. Well, it's my same quandary. If I am already exiting, if I'm not exiting, go to 131. If I am exiting, I think I want to do a break out of the loop. Okay, so I'm going to flip the logic. Okay. Yeah. So hey, we've got this game. It's an old 1980s basic game, and we're trying to convert it to a modern language, and then structure the program and basically modernize it. Okay. So let me. I'm going to have to look up the labeled break. I'm kind of in the middle of the change, and unfortunately, it's not a very smooth refactoring. Okay, labeled break in Swift. We'll be able to run it in just a minute here. And once that's the case, I think we'll be good. Okay, Swift break statement with for loop. Nested loops. Okay, labeled break, that's the one we want. Okay, we just put a name in front of it. Okay. This is the main loop. And we're going to break out of the main loop. This line goes. Okay, have I done that correctly? We don't need a semicolon, I guess. Okay, so let's run it and see what's going on. Let's hope. Okay, so we're going to have to run through at least one level of aliens to see this. Whoops, the build failed. Cannot find main loop in scope. And main loop in front of... I guess I can make a loop like that. For asteroids per line in 1.10. Okay, is that better? Okay. Can't break the other way. Immutable value asteroids per line was never used. Well, that's not really true. This is asteroids per line. And this is asteroids per line. I guess I got to be consistent about this. We don't need that anymore. Okay. Loop vars. This becomes asteroid per line. Okay, so let's try. No, tell me where we met or saw each other. We were on Twitch a few months back here. Okay, well, we have a loop. We have the start, so that's a good sign. Let's see if our ships are there. Yeah. So we're doing 1 star per line. Now we see there's 2 stars per line. Can I move fast enough? No. Okay. Waves -1 is suspicious to me. All right. But I think we're still... Okay, Twitch. Cool. Nice to have you back. All right, let's commit this. Create... Yeah, I thought it must be months ago. Outer loop in Swift. Or maybe convert outer loop to Swift. Was I working on Elm at that point, or was it the sort table stuff? Okay, so I'm going to delete this comment. We're just going to clean up comments now. And we're getting very close. Okay. Too far. Okay. Yeah. Okay. We got a 141. We have to go there. Okay, so at the end of our loop, we were supposed to fall through. So let's do that. So I guess I didn't go far enough to make that go. Let's make sure this is, I don't know if I can play it long enough to trigger the levels. That would be a challenge. It basically runs through 1 star per line, 2 stars per line, up to, I think, 10 stars per line. That NA was 1 to 10. And if you survive all those, then it starts over again. So, I don't know. I don't think I can manage it. No. Waves -1 does seem suspicious to me. Okay. Okay, I don't know. I'm playing loose here in some ways with this stuff, but I think it's okay. We still got to get these loop variables out. Yeah, those should not be here. Score plus asteroids per line. Yeah, score 0, waves -1. That's indicative of me messing this up. Waves is now loop variables. Okay. Cannot find asteroids per line. Well, the issue is the loop variable is local. Okay, well, we may pass this down. So the issue is we've got this, we were trying to get to the asteroids per line. Before that was the global variable because everything's global and basic. We've got a local variable for our loop, but we want to put that down here and deal with it. I don't think it's necessarily the best place for it, but let's pass it in. Okay, so this is asteroids per line of type int, and we got to find handle move and pass in asteroids per line. Okay, I think this will fix the score and wave thing. All right. Can tell I'm getting better. Okay. Score 1960, waves 3. That sounds more like it. Okay. Alrighty, so what do we got left? We come into line 35. We do a fall through to 95. I don't think anybody references 95 anymore. Oh no, we do in our GOTO. Okay. Yeah, right here. And we had it down here too. Okay. So how about this one? 141. Okay, those are irrelevant. So everything that goes on in here can come up into there. And now the 141 case is nothing. Okay. Okay. Let's see. So that was line 141 we eliminated. We're close. We're down to just a couple line numbers. And I'll see if I can just run it and quickly get a boom. All right. 190 wave 0. We didn't get through the first wave. Okay. Oh. Well, I hope it was good advice. If it was graduate, then I guess you did it. Alrighty, so we got rid of 141. Okay, so now where we are, you come in, line 35, you fall through to 95. That's still true, because this is like the intro stuff. When somebody comes back, okay, I'm going to make... I'm going to try and turn this into a flag, this go to 95. And I want to basically, I think what I want to say is should continue. Although I think it's probably, maybe we can just do this. Okay, so yeah, I don't know. I'll turn it into flags and then we'll work on it. How's that? Okay, so I think what I'm saying is in this case, should continue is true, and in this case it's false. All right, so I'm going to use another flag up here. I'm going to say var should continue, and it starts out true. And then I'm going to say while should continue. Okay. And where does this end? Well, it's pretty much down here. Let's see. It's down here. Okay. And then I shouldn't have any labels inside. Okay, now we got to figure out where you mutate it. Should continue is true. If you get here, it's definitely false. Well, right, it's true. Should continue. If you still got lives remaining, you should continue. If you said exit, it should be false. Well, it already is false. It already is false. Okay. So in that case, if you lost, you hit a boom, you come in here. If you still have lives remaining, we should continue. If you didn't have lives remaining, you should not. Oh, it started out true. Okay, let's make it false here. Let's be explicit, I guess, in both cases, and we'll be happier in the end, I think. All right, already exiting. We're not going to worry about that one. Break the main loop. Okay, now we come here. If lives remaining greater than 0, then we want to continue. And this is the same argument here. Okay. Now, do you need the GOTO 95? I think GOTO 95, that's taking the place of should continue. So GOTO 95 was jump to the top of the loop, and then should continue true. It puts us at the top of that loop. Should we continue? Yes. Okay. So I don't think we need the GOTO 95s anymore. Okay. The should continue false. Well, we're going to come down here, and we're at the bottom of that loop. We hit a GOTO 0. It's going to say GOTO 0, and it's going to exit out of the main loop. Okay, so I think we're okay. Well, you must have had a weird year with COVID and all that stuff, huh? Was it all remote learning and online and and here you are wanting to get out? Okay, we get to our second. Okay, waves 1. Think we're missing it? Yeah. Okay. All right. Again, I think we're getting there. All right. So 95 now. Nobody should be referencing that. All right. So we don't need the fall through. We don't need the case 95. All right. We got 2 GOTO zeros. All right. We got rid of 95. Let's make sure this works. And I don't know, I'm trying to take small steps, but I was a little sloppy on those loops. It's a little tricky to get out of them just right. But I think we will see that we have the loop structure correct with double nested loops and ways out of it, and that should keep us going. Missed. Okay, should get a boom. Yeah. All right. Online school still. Okay. Well, a few more weeks or another year, she'll be all set, huh? Delete line 95. Okay. So what we're trying to get to is we introduced this mechanism, the line. So we have a big state machine that's built around line numbers. But at this point, the GOTOs, I think, are all GOTO 0. GOTO 95, that's a commented. GOTO 0, GOTO 95 commented. Okay. So what that tells me is I go in at 35. At some point, I say go to line 0, and we execute the rest of this giant thing. We hit break. It says, oh, what's your line number? Well, line is 0. Okay, so I don't think I need any of this anymore. The delay 10 will decide if we want to slow it down a little, but I think we can get rid of all this now. Okay, so we have our function. It just starts in doing what it does. We don't need the break. We don't need the default. And I don't think we need that. Am I still one more? No. Okay. Something's goofy. X. Did I go too far? Do I need this gone too? Yeah. Okay. So default. I guess one ended the switch statement, one ended the loop, and then this ended the method. Okay, so let's reformat. Okay, so now we come into our method. We don't mess with line numbers. We just do this stuff. Okay, and I I don't need go to 0 anymore, because if you get here, should continue false, you're going to exit out of this loop and you're not going to continue. Okay, so I'm going to take go to 0 out here and here. All right. And just get burnt too many times. I'm going to run it even though it's probably fine. Okay. And I'm going to die as quickly as possible on this one. Okay, one more life. Should completely stop. And we're done. 3. Something's not quite right. Oops. Oh, don't do that. Whatever you just did. Okay. Well, I think what we're going to do, let's see. Let's take a break. We've been going for almost an hour. So we'll take a break. We'll come back. I think we'll see what's going on at this level and see if we can straighten out this should continue stuff and make that all go. Okay, so just like 2 or 3 minutes. I'll see you in a bit. All right, welcome back. Okay, so what I want to try and do is track through the people who are saying continue false. Basically, I believe every path that goes through continue false pokes this. That tells me I can put the continue false, or I can put the poke after that loop. Okay, so let me delete the junk. We got some up here. Okay, so what we've done, I mean, this is actually a pretty good shift. I mean, I think there's some imperfection here, but we got rid of all the GOTOs. Okay, so that was a trip. Okay, it took some work, but now we're in, everything in here is Swift. I don't think we're using these loop variables anymore. Okay, so I think I'm just going to turn this into nothing. Well, let's find the references. I guess that's the way to go. Loop vars. Okay, this is implementation, declaration, using it in for loop. Okay, so all this stuff, I have all the mechanism to support basic down on the bottom here, but nobody's calling go to, for loop, next loop, delay we're calling, rand we're calling, nobody's calling go sub return, peek and poke we're calling. So, and print we're calling. So the ones that support the basic, they aren't being used, and this was in there supporting the basic. So I think this is just an empty thing. We don't have any variables for it anymore. We turn those into just regular old variables. Okay, so that's something. Let's go over to do. Okay, so eliminate GOTOs in main body. We've done that. Let's take some of these names and deal with them. Well, let's do this one first. I guess I'll move this down. Okay, R goes to seed or something like that. R. And this is just for the random numbers. So let's refactor. What? Oh. rename random seed. Okay, and you see it's only being used 2 places. It sets up the initials, which seed do we use, which random numbers, and uses it here to start the seed. If you call it more than once with the same seed in a row, it just keeps getting the next stuff in the sequence, so that's okay. All right, so I'm happy with that one, random seed. What else did we say? X keyboard subroutine LA is level. Okay, so LA, rename that to level. Okay. And we got one more X. I think we said that was keystroke or something. Let's see how that's used. Down in our subroutine. Oh, that's really the keyboard. Maybe keyboard. X is keyboard. Key matrix is really what it is. Okay. So we got rid of all those ugly 1-letter variable names or 2-letter variable names. Okay. And let's run this. I don't think there's any mistakes with these random. Oh, we can clean that comment out. Now, I do think there's a couple bugs in this thing, and we'll see if we can find it. But, yep, that's booming. Okay. For 30 by 32 screens. I don't see any other interesting comments. That's probably useful. Okay. Let's commit this. So we did rename variables and delete a comment. All right. LA to level. That one. Okay, these two are done. Turn lost into a Boolean. Okay, so well, let's see what we can do. So let's say Boolean is false. I don't think we need these old names anymore. Okay, and it should complain. Here we go. Bool. If lost is not 0, so I guess that's if lost. Lost is false. Should be one more. There it is. It's not 0. It is. We are saying it's lost. Okay. Notice it printed the score on the waves, so we know this is. Yeah. So if it was a space, we just return. Otherwise, we deal all this stuff. Okay. So lost is a Boolean. I think to make it legit, we'll have to run 3 times, and you really lost. Or 3.5, I guess, is what it seems to be doing. And I don't know if that bug was there before. That's the worrying part. I'm going to have to think on this for loop thing, because that should have been smoother. I'm doing this just kind of more ways to refactor, and you could do assembly code with this approach if you really needed to. um, whether that'll work, I don't know. Basically, every register you pretend is a variable, and every status flag is a variable, and it's not super hard. It's just very tedious. Okay, I think this stops pretty quick. Yeah. Okay. So that was change lost to a Boolean. Okay, this is more of a comment, and it's kind of what we've been doing today. Kind of information about that. All right. So transliterate basic to Swift done. Simulate the environment, yeah, basically done. Refactor is where we're working on. Okay. And let's just let's spend some time refactoring. Okay. So the type of refactoring I want to do, though, I don't know, it's a little obscure maybe. What I'm going to do is I'm going to find the places where should continue is false. They both have poke 530s. So what should continue false does, if should continue is false, we exit this loop. Okay, so after this loop, we do the stuff you would do with should continue false. Okay, so I'm going to move this down. All right. And so I don't need this poke anymore, and I don't need this poke anymore. Okay, what else is going on? Well, I've got the same, I mean, this could be different. Well, okay, if lives remaining greater than 0 decides whether it's true or false, that's the only uses of should continue except for the reference up top. Okay, so that tells me should continue true is the same as lives remaining greater than 0. So my argument is should continue is really a shortcut name for lives remaining greater than 0, and that I can do that here. Okay, now nobody's looking at should continue. Okay, so let's see if this works. That's the first question. But if it does, I should be able to delete those lines, because all it does is set a variable I don't care about. Okay. Such slow startup. All right. Boom. Boom. Our goal is to bust out so should continue ends up false, lives remaining ends 0, and yeah, we don't get anywhere. All right, why you get a little bit of that extra bit, I don't know, but the controls are not active and we're not going. So all right, so I got rid of should continue. This should be able to delete, and this should be able to delete. Okay, so the condition is what's driving it now. Okay. And continue. I've still got that variable. Okay. Never used. All right. Let's run this. Oh, that's tests. Okay, well, we haven't done those in a while. No harm in that. Okay. We got rid of should continue. Should continue. Okay, so this is all we're trying to untangle these exit conditions. Okay. We run through the asteroids per line. We don't think these even matter for it. I think that's a true thing. Okay, this already exiting thing, I would love to get rid of that. Okay, if you lost, that's handle move. If handle move comes out and says you lost, then we're going to clear the screen. We're going to say already exiting is true. And we're going to break out of the main loop. It starts out false. It only gets true under the one circumstance. All right, so I'm going to claim the only uses of already exiting, the only use is right here. If it's already exiting, we're going to close. Let's see, are we in a loop? We are in a loop. I would like to break the main loop here. All right, I don't know. It's all a little big for me to see. All right, let's see where this loop is. Okay, so already exiting is the inner loop. This loop. Should we break the inner loop if you lost? I think we should. We're going through the levels and you lost. I'm going to try that here. I'm going to call this. I don't know. This may be changing something. Cannot find label main loop in scope. Oh. This loop is there. This one is here. This is the if condition. So we are going to continue this loop. Even if you lost, okay, is that? I'm going to drive myself crazy on this. Okay, after a long, hard day at work, I guess. Let's see. Poke. Okay, I'm going to go back to the original basic. If we lost, I think we really do try and break out of the main loop. Do we have to break the inner loop? Okay, go look at the basic. See if we've done this correctly. So you get here, you've lost, then jump to 200. We reset lost to false. We print. We jump to 150, which, if we have more lives remaining, goes back to 95 and starts over. Okay, so I think if we lose, we're in the middle of this loop here. Yeah, so here's an A loop. Here's the LW loop, the one we're in, wavelength. If we hit the lost, we're trying to exit out of, well, basically we end up at either 95 or ending. So if we end up at 95, we're trying to exit out of both loops. So I'm going to have to make that exit inner loop. And since I'm not allowed to jump out of two loops, apparently, I don't know if this example shows that. Okay. Label our loops. If j equals 3, break outer loop. No, that should be legal. Oh, it's got to be a for loop. Yep. Okay. So let's do for wave length in this stuff. Print. Okay. That should be okay. That should be like we are. Poke refers to. Well, what did I? Oh, I didn't put a brace. Okay. Everybody's happy. Wavelength is never used. Interesting. Okay. Let's see what that wavelength is. That was LW. Let's find LW. They're right. Okay. You can break to outer loop from 2 for loops though. So let's try it. Well, no, we're gonna make sure this is running. Okay. I guess if we die once and it restarts us, we're probably on track. Yep. And net score. And start over. Okay. I think we're on track. All right, so this can go. This can be nothing because we're not looking at it. And we'll commit this. Okay, so change inner loop to a true for loop. All right, now I believe this can be that. And I feel like it's changing something, so let's be alert. And I don't think we need this anymore. We couldn't do the break before. Well, originally we had the basic style loops, and we couldn't do a break out of those because we can't jump between basic loops and Swift loops. We can't even jump between two kinds of Swift loops. Okay, there we are. Boom. Score. Start over. You can't boom when you want to. Okay. And let's go for that third one because I feel like this may change that weird end behavior, but we'll see. No? Yes. Okay, so we did have an error in there. This exiting, we let the inner loop run all the way through, and now we don't. So that's what happened. So we realized we'd lost, and yet it kind of filled out the rest of the wave, and that was the extra stuff. Okay, let's see. So that was just a comment. So we use break out of main loop when you've lost. Okay. Already exiting was written to but never read. Okay. Already exiting. We don't need it. Okay. I'm going to trust the compiler. Okay. I don't like jumping out of two loops at once, but it does seem like something is, I don't know. It seems a little it seems like the way we have to do this, I guess. Unless we can find a way to flip it around. Now, the interesting thing to me is, well, maybe it's the unfortunate thing. This subroutine, on the one hand, like this chunk here, that's pretty clearly just doing the keyboard stuff. So poke 530 is a keyboard handling thing. It's do you turn Control C handling on or off. This turns it off. Then you poke 57088. That is how you read a keyboard. Let's see if I got the picture still. I think I have it here. Yeah. So this is the old way. You don't get any USB keyboards back in 1980, whatever. The keyboard, when you do the poke, you're saying which rows of the key matrix do I want to check for. And then when you do the peak, so when you do the poke, it turns the voltage on whichever ones you specify. So if you say 255, you're turning the voltage on all of them. And when you say peak, you're saying, tell me which columns are activated. So you could hit the X key and the V key at the same time, and that would light up this column, C5 and C7. Those little triangles are the switch. It's basically connecting these wires. The vertical wires don't overlap, or they overlap, but there's air, and the air is connected by the switch. Okay, so you're finding out which keys, but you have situations you can't tell the difference, right? If you, let's say we had N and G and B and H or whatever that is, we would see these two bits lit up, and we would light up these two bits and then see these two bits lit up. We wouldn't know, are you holding B and H or B and N or G and H or G and N? You can't tell so much. That's why you're allowed to poke one at a time, so you could actually pull everything. And probably that's what the basic keyboard handling does. It probably has a little loop that, zips through the rows or the columns and then one at a time checks the other. Okay, so what I see here is keyboard handling and a little bit of decision making, but we're figuring out which key do we have, and I've mapped those arrows to basically set these bits in the matrix, the keyboard matrix. Okay, so the left arrow, sets a B, and the right arrow sets an N, basically. And so this part is fine. Then this stuff is all like, what's the consequences of this thing? Well, all this stuff boom down. Okay, this one is easy. If the space is empty, then it's fine to move the ship there. Okay, so you can move the ship. Otherwise, you lost. Okay, even though down here we say lost is true, it's like really it happened way up there, and you can see lives remaining and all that stuff. So what I want to do, well, let me do it the proper way. Actually, Swift doesn't like it. Okay, so handle move. Can I inline? I don't think I can. Right, there's no inline here. Okay, what I want to do is I actually want to keep this fine, but this stuff, I want to pull this back up. Okay, so I imagine that I inlined this method and then I re-extracted just these 5 lines and named them handle move again. Okay, but I got to pull these up. There's only one call to handle move, so I know where to put this code. It happened after this stuff in handle move, and I'm going to put it up here and be right here. Okay, so that's the effect of an inline extract, and you've changed your mind about how you extract. What I see is, like, this is that simple case. This is all the stuff that sets lost equal true, and then we check lost, and if it's true, then we do this stuff. Okay, so we definitely have opportunities here. Okay, so I'm gonna say I inlined the bottom half of handle move. Okay, I didn't save. Yeah. All right, and I guess I should run it. That's a moderate change. Okay. Here we go. So yeah, this thing maps to keyboard B and clear the keyboard. So I really should make this, and once I get this cleaned up, I'm gonna make this so the pressing on it starts the keystrokes and moving off it stops them. But I'm hoping that's a little more natural lineup. Okay. All right, so let's see if we can get a little ways here. Okay. And you can see sometimes you can get trapped. There's little tunnels that start forming. Okay, yeah, if you were stuck over here, you'd be stuck. And boom. Okay. Yeah. All right. So we lost, and that's fine. So, okay. Alrighty. So one thing I can see, the easy thing to see, this stuff. Well, lost equals true. Then if lost, well, the only way this gets set is if we came through this path. So really, this is not doing anything. Nobody else looks at lost. It gets initialized up here somewhere. Lost starts out false. Let's make sure about that statement. Lost commented back to the top. Okay, so I'm taking out the closing brace and another opening brace, so that is okay. Now, nobody else was looking at that. Okay. The thing I would like to do, I would like to break... I'm going to make sure we're doing this right. Okay. I mean, if we want to move, that all seems fine. Otherwise, we have to get out of the main loop and increment levels. And I don't think that's quite right. Main loop. Okay, there's main loop. Your levels do go up, but then you're back at this loop, the lives remaining greater than 0. When do we get there? Well, okay. If you survive 10 asteroids per line, you survive the wave with 1 asteroid per line, 2, 3, 4, 5, up to 10, then we just increment your level, and now the waves are longer. When the wave's longer, that's this bit. Okay, so 20, you start out with 20, level starts out 1, right? Yeah, so this is 5 times 0. So you start with 20, and then you add 5 more for each level. Okay, but I guess what I'm trying to figure out is where are the places... All right, maybe I should say it this way. What should happen if you find you've got a space, then I don't think... I mean, this is completely right. The problem is if you don't find a space, then you need to do something. And maybe this is where the lost comes in. Maybe I was too quick to delete it. If you lost, like what if I said lost equals true and do a break, and then when you exit the break, you're down here. I would say if lost, then do all this stuff. And either way, you're going to increment the level and see if there's lives remaining. Okay. And lost needs to reset. Okay, let's try it again. Lost is false. Okay. This is probably the worst change I'm going to make. Okay, if this happens, then you lost. That's true. All this stuff. Well, it can happen before or after you break, but we're going to say break the main loop. And then here, if you lost, then do this stuff. And I'm going to set lost equal false now. Asteroids per line. Okay. Anything else? Okay. Before we did it by passing a parameter, I'm gonna create another variable. Asteroids per line. Okay, it's a little bit of a liar, because asteroids per line, you could be in here. It could go down again. I guess that's the wave you're on. All right, so let's track waves. Okay, and then asteroids per line is really waves. Okay, we're keeping that relationship. And then down here, asteroids per line is really waves. And that's always reset if it needs to be reset. And then my claim is this stuff is copied below. Okay. Clean up a little. And we'll deal with this more, but I'm trying to get this inner loop a little more clear. Okay, I think that's legit. So we said you had all this stuff going on. We're gonna break out of it anyway. When we break out, we're now going to check for if we lost, and we'll reset it because we've already figured out we've lost. And if we've lost, then we're going to do all this stuff. That's a little funny, but okay. Run this. I suppose if you lose once, you're going to reset, and we'll see that happen. Boom. Okay. And we go again. Boom. Okay. One more. I don't know if I can try and run into this thing. You can't do it when you want to, that's for sure. Okay, that's 3 waves. Or 3. Yeah. Okay. Nice. All right. So we reorganized main loop to handle crashes outside of it. Okay. All right. Okay. I'm getting happier. So you do all this stuff. Delay 30 if asteroids this, whatever. This is really the heart of it. It would be nice to see that dealt with somewhere. Okay. I don't know. This is still awkward. The boom score. This, I'm kind of ready to change something there. I don't know. What I noticed is when you make your last wave and you die the third time, it still executes this print last, so it clears the screen for you. I don't know. Alrighty. Let's see. What can we start doing? Okay, one thing I want to do. I got some things capitalized and some things lowercased. That seems off. Let's see if we can change this to print. Rename lowercase print. Okay, and I'm gonna clean run my tests. I want to make sure nobody's like importing a different print and messing us up. So the capital letter version was very basic, not very, not very, not very swift. Yay. Okay. Let's commit that. The other one was peak. Same deal, run tests. All right, and probably should call that the official name of rename. Oh, I really would like to get this somewhere else, I think. But, all right. The lost is... Okay, what else we got? Level plus 47. Yeah, this is really... All right. Well, these numbers, I don't know. I'm just going to do a little formatting. Get this, just try and get the look. Okay. Again, I don't think those tests are going to catch it very much. All right, now, what else can we do? I think key matrix is only referenced in our subroutine, which is now a function. All right. And what do we say? Var matrix event equals 0. All right, let's just say var key matrix. Okay. Yeah, I think that's legit. We poke, then we read once, and that's all we're going to do. Okay, so key matrix ship we need to know. We got these random pokes. Okay. All right, yeah, so all we look at is ship here, right? We look at the keystrokes and the ship. And yeah, so keystrokes and the ship. Okay, so that tells me ship needs to be public or, global. I don't think any of this stuff does. Let's pull these in, run. See what happens. All right, we'll build tests. Okay, and then, well, random seed. Last random seed's not really relevant, but random seed, that's even just a constant. So let's pull that as a constant. I don't know. I forget. Do I say constant Swift? Const let random seed equal 8484. Okay, score is variable. We can just say equals 0. We did that up there. Okay. Level is 1. Asteroid base is this horrendous thing. And ship starts here. Well, that one's global. We'll leave that. These three can go. This is outside of the main loop, so this one can be just equals 3. This is a let. Asteroid base, okay. I'm going to pull that up here too. Let's move it down a little bit. Okay. Constant. Lost is false. I think we want that to start false. Yeah. Waves is 0. Ship. Okay. So we sort of reorganized declarations, I guess. Well, let me test it. I don't think those tests could affect anything. And I think the compiler would tell us, but we'll run it too. Okay. Yeah, I did something. Oh. Yeah, print is... Oh, dear. Let's see. We're doing that down here. Let's find the print. Next for... It's in the memory stuff. There it is. Okay, we don't want that to happen. That's what comes of using the same word. And really, I was thinking we should just get rid of that for now anyway. This is the peak, and notice what we do. We have a screen section, and then we check that keyboard matrix position. Like random numbers out of who knows where, but that's the way, that's the definition. Okay, so let's run again. Yeah, that was a ways back. I can tell it's late at night. I worked all day. I'm getting fuzzy. All right, that's poke. We did the same thing. Okay, where's poke? Any other prints out there? I don't think so. And maybe we should keep those. I don't know. How do you miss? Okay, one more. Think we'll get there in time? Yep. All right. Knows Okay. Let's see. So we reordered declarations, commented out. Not implemented calls to print. Notice that print is already Swift's word for console print. Now I almost can see I maybe want to do this a little differently. So peak of 57088, what were we getting here? Were we getting any peaks? I don't think so. Let's make sure. I'm thinking now, like maybe that is the right place. We'll just write stuff to the console if we get something not implemented, and we'll just implement the 530 calls. And maybe we'll pick up there tomorrow. Okay. I don't think there's any other peaks other than the keyboard stuff and the screen stuff, which is legit. Okay. Yeah. So this will show up in our basic code. I'm okay with that. All right. So let's talk about this one, poke. I think the next step, well, we did some refactor some. Okay. We're going to refactor, but I think one of the things we're going to do is make poke handle 530, which is the control C handling. Make poke write to screen for not implemented. And refactor more. Okay. I think that's where we'll leave it. So we did a bunch of stuff. We finished all that GOTO stuff. That was a big thing. There were converting to Swift loops was not a direct process. I don't know how I want to say this. Was not safe. That's probably the true thing I want to say about it. Normally, refactoring is we try and do things in a way that we just don't want to make mistakes. And I made a mistake in there, so that tells me that it's possible. And I don't know how to not make. I'm not sure how to deal with that. The challenge was you had control paths that had to flow through. Maybe I should say it here. Handle GOTOs in body, but also had to handle exit. Okay. Hopefully that gives me enough to go on. But yeah, that was not pretty. Okay. The come from analysis, I think that mostly went good. We did some inlining. I should mention that one. Inline the movement and error handling for handle move. Now it only moves the ship, reads the keyboard and moves the ship. Okay, and we refactored some. Mostly, well, loop reorganization and renames and declarations. Okay. We'll commit where we are. I'm going to have to diff that. Oh, yeah. We made peak. Right to the screen if there's a not implemented value. All right. Okay, well, thanks for joining me. I think I will have a session on Friday. I don't know if it'll be morning or afternoon. And I don't know. I'm going to have to work out a new schedule. I think I'm pretty much tied up Monday through Thursday during the days is a pretty safe bet. So we'll see what happens. Anyway, take care. Hope this has been a little enlightening, and hope I see you again in the future. Thanks. Bye-bye.